Hello, dear students. In this video, I'm going to give you the list of formula from the chapter wave optics. So this is the 10th chapter from second PhD physics syllabus. So this is the brief syllabus or the topics which are there in this chapter. So first of all, we'll learn about the wavefront in this chapter. So then how plane wavefront is produced, how spherical wavefront is produced, how cylindrical wavefront is produced. All those things we will study. And we have the Huygens principle, which is very important for 2 mark in board level. Then the refraction of plane wave is there. Here the most important thing is the derivation for Snell's law. Then we have the reflection of plane wave by the plane surface, so maybe at denser medium or rarer medium. So then the derivation law of reflection is there, that also you study this chapter. Then we have the explanation of refraction of the plane wave, so through thin prism. So these diagrams are very important, which explains this. And then we have using diagram is there, no? So diagrams are important. Then we have the coherent sources and incoherent sources. Theory of interference is very important. Based on that, you will get more questions in the competitive examinations. I will give the list of formula from the chapter, sorry, on the topic in this video. So arriving at the conditions for constructive and destructive interference is important. Constructive and destructive interferences. Then we have the Young's double slit case experiment is very important. So based on that also you can expect the formula derivation is got deleted. As of now only the formula is there for competitive exams. Then we have the diffraction. So explanation of phenomena and diffraction at single slit is very important. And then we have the conditions for minima and maxima, that also I will give. Then we have the intensity distribution curve for interference as well as diffraction. Then we have the last concept, that is called polarization. So in that we have a law called Malus law, which is very important. So based on that also you will get questions in competitive exams. So here I am intended to give the list of formulas, so I will try to focus more on the formula base. We have the introduction here. First of all, the corpuscular model was described by Descartes, but later it was in detail explained by Newton. So in his famous books called Optics. So then after a few years, Christian Huygens has proposed the wave theory of light, and the wave theory of light was proved by Thomas Young in his famous experiment called interference experiment. It is also called YDS experiment, Young's double slit experiment. Okay, then Maxwell has given developed four different equations in electromagnetism, and explained the electromagnetic wave nature of light. So then he has proved light waves are transverse waves. So we'll learn one by one. First of all, we have the relation between the phase difference and path difference. So phase difference is represented by phi or delta phi, that is given by 2 pi by lambda times path difference. So path difference is represented by delta x. So or if you want delta x, so the phase difference is given by means in place of just a minute. Yeah. So if you want to write the expression for delta x, then it will become lambda divided by 2 pi into delta phi. So these two are very important formulae. So you may get numerical type questions based on this, or MCQ type questions also in your board examination. So try to practice this. Then we have theory of interference. So what is interference? Let's consider here. So two waves which are moving in one particular direction, when they merge each other, so they form a new wave. So here we have y1 which merges with y2, and they produce a new wave, that is y. So let us write some formula here. Let's consider y1 is the wave which is merging with y2. Let us consider for an instant of time y1 is equal to a sine omega t. So you can take cos omega t also, it's up to you, but here I will take a sine omega t and b sine omega t. Let's consider some phase difference phi or delta phi. So when these two waves merge each other, we will get a new wave of amplitude y at a particular instant of time. So ultimately, if you after adding a sin omega t and b sin omega t, we will get the final equation as r is equal to r into sin omega t plus phi, sin omega t plus phi. Actually phi angle also will change, so we'll write it as theta. This is theta. So now here we have the expression for resultant amplitude on that. So where r is resultant amplitude, resultant amplitude, that is r is equal to square root of a square plus b square plus 2ab into cos phi. Okay, resultant amplitude. Then we have um, condition for constructive and destructive interference. Before that I will give the resultant intensity also. Resultant intensity I is equal to I1 plus I2 plus 2 root I1 I2 cos phi, root I1 I2 cos phi. So then we have condition for constructive interference and destructive interference. Interference and we have destructive interference. So here if I write the conditions for constructive interference, so for constructive interference, so r value should be equal to a plus b. So the amplitude should get added up to get a plus b for r. So the cos phi value will take it as 1. So if you substitute that value here, cos phi is equal to 1, you will get a plus b whole square formula. So under the root, you will get a plus b. So for cos phi to become 1, so phi value should be how much? 2n pi. So I'll take it as 2n pi. This is called phase difference. So you can calculate the path difference here. So path difference is given by lambda divided by 2 pi into phase difference delta phi. So from that you will get path difference is equal to 2 pi will get cancelled, you will get n lambda. So path difference is given by n lambda. Okay, so then we have resultant intensity I is equal to amplitude square, so a plus b whole square. So then we have destructive interference. For that r value should be equal to a minus b. To get a minus b, you should take cos phi value as minus 1. So we'll get cos phi value is equal to minus 1. For what value of phi will get minus 1? We'll get 2n minus 1 pi. 2n minus 1 pi. So therefore the path difference is equal to phase difference is 2n minus 1 pi. Path difference is you can substitute that in this equation, that is lambda divided by 2 pi. So 2 pi will get cancelled, lambda by 2 will be there. So we'll get 2n minus 1 lambda by 2, lambda by 2. So here we have phi value and path difference delta x. So intensity becomes I is equal to a minus b whole square. So here we will get minimum intensity, here we will get maximum intensity. So here if I take the ratio of minimum intensity to maximum intensity, what do you get? I maximum divided by I minimum I will take. So I maximum divided by I minimum is given by, so we get a plus b whole square divided by a minus b whole square. So this can also be written as root I1 plus root I2 whole square. Why? Because intensity is directly proportional to amplitude square. Root I is directly proportional to A. So here I will write I1 in place of A, I2 in place of B. So root I1 minus root I2 whole square. This can also be written as I maximum divided by I minimum is equal to A divided by B plus 1 whole square divided by A divided by B minus 1 whole square, that is equal to root of I1 by I2 plus 1 whole square divided by root of I1 by I2 minus 1 whole square. So this is very important formula based on which you can get questions. So then if in case I1 is equal to I2 is equal to some value I0 I will take. So what happens to this equation? I is equal to we have this equation I1 plus I2 plus 2 root I1 I2 cos phi. So if we substitute I0 in place of I1 and I2, the final equation that you get is 4I0 cos square phi by 2. Okay, so that is very important. So where 4I0 is the maximum intensity. 4I0 is maximum intensity. So then we have Young's double slit experiment. So where the formula for fringe width is given by beta is equal to lambda d by small d, and we have the formula for distance of nth bright fringe and distance of nth dark fringe also. You can check that in this experiment. So I'm not going to explain the experiment here. So this is the expression for fringe width. Beta is equal to lambda d by small d. Okay, let me give some formulae. So if I consider Young's double slit experiment here, the distance between the slits S1 and S2 is small d. This is slit S1, this is slit S2. From these two slits, so you will get what is this light. So they interfere each other, and interference pattern is formed on the screen. Interference pattern is formed on the screen. So there will be alternate bright and dark fringes here, right? Having the same intensity. So this is called central bright fringe. This is the first bright fringe. This is the second bright fringe. This is the first dark fringe. This is the second dark fringe, like this. Okay, now so if I consider, so the distance between the first bright fringe to the next bright fringe is given by fringe width, or first dark fringe to next dark fringe. So distance between any two consecutive bright fringes and dark fringes is beta. So what is the distance of nth bright fringe, sir? That is xn is equal to n beta. That is also given by n lambda d by small d. And what is the distance of nth dark fringe? Xn is equal to 2n minus 1 lambda d by 2d, or this can also written as 2n minus 1 beta divided by 2. So this is the distance of nth dark fringe. This is the distance of nth bright fringe. Nth bright fringe. This is for nth dark fringe. Okay. Then we have, let's consider the width of first slit is W1. Then width of second slit is W2. The intensities of lights coming from two slits are in the ratio I1 by I2, that can also be written as amplitude square divided by amplitude square from both the slits respectively. So this is also very important for competitive exams. Then we have angular width formula. So that is given by theta is equal to beta divided by capital D, which is equal to lambda divided by small d. Hope you know the terminologies and all, where lambda is wavelength, beta is fringe width, capital D is the distance between the screen and the slits. So small d is the distance between the slits. So here we have the source whose wavelength is lambda. Okay, all these things you should know. The slit width W1 and W2 are the slit widths. Slit widths. Okay, so these are the different formulae. Then we have the concept of diffraction, wherein you will learn the diffraction at single slit. There the condition for minima and maxima is important. So condition for maxima is 2n minus 1 lambda by, it's better to write 2n minus 1 lambda by 2a, and condition for minima is sin theta is equal to n lambda. You can also write a sin theta is equal to n lambda. Here a sin theta is equal to 2n minus 1. Let me write it separately as we don't have much space. So let me take it here. A sin theta is equal to 2n minus 1 lambda by 2. So condition for maxima and condition for minima are given, which are very important. Then we have the concept of polarization. This is done, right? So this is the intensity distribution graph. You can just learn that in theory concept. Then you have the concept of polarization. So what is polarization? The conversion of unpolarized light to polarized light is called polarization. So here the most important thing is Malus law. So if you consider here, unpolarized light of intensity 2 I naught falls on the polarizer. So it is having a path axis in this direction along y-axis. So the polarizer filters the unpolarized light, and the light coming from the polarizer will be having the intensity I naught. So after passing through the polarizer, it filters it by an amount I naught. So when it is allowed to pass through analyzer, which is making an angle theta with the polarizer, then the intensity of transmitted light is directly proportional to cos square theta. Cos square theta. So I is directly proportional to cos theta. So what do you get from here? I is directly proportional to cos theta. So I is equal to I naught cos square theta. I naught cos square theta. This is called Malus law. Okay, so Malus law states that the intensity of transmitted light is directly proportional to the square of the cosine of the angle between the path axis of polarizer and the analyzer. Okay, so it's very important. So this is all about the wave optics chapter. So you try to solve more number of questions based on this, so that it will help you for your board examination as well as competitive examinations. We'll come back to you with the new chapter. Till then, take care. Bye.